All right. To multiply polynomials, these are your notes, you guys. This will be our next unit that we're going into. To multiply polynomials, you have to be able to find the area of a rectangle. The area of a rectangle formula is area equals base times height. And as you see on the rectangle, the height is the same on each side. The length is the same on each side. And the base could be on the top or the bottom, okay? Okay, and another formula, if you're not used to seeing base times height, is length times width, but that gets confusing to me. So I would just stick with base times height. But whatever you want to do is cool. Now, let's practice finding the area of a rectangle. So the area of a rectangle, what we got to do is use our formula. So we have a rectangle. We have our base, and we have our height. So it's going to be 4 times 3. The base, 4 times 3 equals A, which is area. Area is 12. So the area on the inside of this whole, the area inside this rectangle is 12. And that's all you do. Now, sometimes they'll set it up on different types of worksheets and different types of software where they're not going to use the bottom as the base and the height right here. They'll use the base at the top, which is still the base because these are the same. So it'd be the same thing. A equals base 4, this is the base, times the height, which our height is 3. So A equals 12. So it works both ways. Now, let's go to example 2, because this is just the very beginning. We're not worried about, we're not really going into just finding only areas of rectangles. We're gonna go into some more, we're gonna keep getting more difficult as we go. So now we have a rectangle right here, and there's 2 boxes. So let's look. What's our base? Well, the base is right here. We see our numbers are right here. So the base is down here, and the height is over here. But what we have to do is we have to find the base of each individual rectangle to make this work. Okay, so what you do is you do 2, the base, times 5, which is the height. So you have 2 times 5, which is 2 times 5. That gives us 10. Then we find this 5 is really the height right here, so it's 5 times 3, just like your multiplication tables, how they move together and you would multiply like a 30 by 30 multiplication table. So 3, the base, times the height, so 3 times 5. 3 times 5, so it'd be 3 times 5, and that's 15. So really, I just take my pen and say, oh, 2 times 5, that moves here, that's where you put it. 5 times 3, that moves here together, and that's where you put that answer. So the base, the answer for this would be, well, since we did all of our formulas, we have to go on the inside, which is 10 and 15. To get the area of a rectangle, you add up all the boxes on the inside, which is 10 plus 15. So really, all we got to do, since we already did that, we don't really need that right there. So it's really just going to be the area. The area will be 10 plus 15, which is 25. Same deal here. It would be the same thing. Your base times your height, which would be 2 times 5, which would be 10, and then 5 times 3, which is 15. And that's...
So can I add the 2 plus the 3 together to get the base?
You can, You can, but for these type of problems, we're just going to set it up like this because we're actually scaffolding this where you can move forward where we're going to be doing actually multiplying polynomials. So you actually can do that, but you can, but we're kind of doing this method so I can set you up for the next way because really it's 2 plus 3 is 5, right? And 5 times 5 is 25, so it would work. You are correct. So let's go to some of the stuff we're going to be learning. We're almost there, you guys. Hold on tight. So now we're going with a rectangle, and we got to find the area of it. Well, we're going to find the area of each individual rectangle. So we take our 2 and our 5. These meet here. So we have base times height, which is 5 times 2, which is 10. Then we have 2 times 2. These meet here just like a multiplication table. So 2 times 2, which is 4. Then we have 5. This is the base. See, the base would be right here for 5. So 5 times 3. These meet here. So 5 times 3, which is 15. And then we have 3 times 2, and these meet here. So 3 times 2 is 6. So to find the area, you add up everything on the inside. So I don't know why I wrote this out right here. I guess I was trying to be extra, but it is what it is. So we're going to go ahead and find the area, which is 10 plus 15 plus 6 plus 4. So 10 plus 15 plus 6 plus 4. So 10 plus 15 is 25, plus 6, 31, plus 4, 35. So the area is 35. And this is the same way right here. You just multiply, these move right here, and that becomes 15. This moves right here. This would be 6. 5 times 2 would be 10. And 2 times 2 is 4. And you'd get the same exact thing. See how 15, 6, 10, 4. So the base can be on top, and the height can be on either side. Okay, just so you know. All right, let's go to some actual polynomials. Before we start polynomials, I want you to look at this real quick. Polynomial. A polynomial is an expression of more than one algebraic term. Okay? A monomial is one term. For instance, a monomial could be 5x. A binomial is 2 terms. So 2 terms would be 5x plus 2. A binomial is also known as a polynomial because it has more than one term. It has 1, 2. Trinomial, 3 terms, which is also a polynomial as well. So we have 5x, let's say, squared plus 2x plus 3. There's 3 terms. That's a polynomial or a trinomial. So we're going to be working on multiplying polynomials. Okay? So to do that, we're going to use finding the area of rectangles to help us do this. So we have 2 times x plus 3. And it's really, to write this out, it's going to be, we have the base times the height. Okay? So this is the area as a product, because we know the area as a product is multiplying. So it's 2 things multiplied by each other. So a product is 2 things multiplied by each other. That gives you the area of a rectangle. Well, also, the area as a sum is when you just add up everything on the inside. And that's add up boxes on the inside. That's all you do. So the area as as product is the same as the area as a sum. Okay, it's base times height equals adding up all the boxes. Okay, so let's do this. Base x times 2, x times 2. Well, there's really a 1 right here, so you would do 1 times 2, and then the x just goes with it, right? That's all there is to it. So 1x times 2 it just goes right there with it. Then we do the base again, times the height. So 3 times 2, these go together. So we have 3 times 2, which is 6. Okay, well, we used our generic rectangle, our box, to help us do this problem. Now all we got to do is add up all the boxes on the inside, and we don't need this stuff anymore. That was just to help us do our multiplication. So we have 2x plus 6. Well, they're not like terms because this doesn't even have a variable with it. Remember, like term is a variable with the same exponent. Well, this doesn't. So it's really just going to be 2x plus 6. So to add up all the boxes is just 2x plus 6. That's it. Okay? Let's go to a little bit harder problem. Okay? Let's go to one where it's x plus 3 times x plus 4. Those are two polynomials multiplied by each other, or two binomials. So since there's two numbers or two terms for each, it's a binomial times a binomial, okay? Well, this is going to be base times height. That's your area as a product. Because product means multiply by each other. To get the area of a rectangle, you do base times height. And then this will give us the area as a sum after we finish the problem with the box method or generic rectangle. It means you just add up all boxes. Okay? So let's do it. So we have now, we have the base on top this time. Oh, that's okay. It's the same deal. We have the height on the sides. We have the height. And we have our base right here. X plus 3. So we're going to go ahead and do it. So x times x. X times x, we'll do it right over here. So x times x gives us, we have to use our exponent properties. When you multiply exponent properties, you add the exponents. When there's nothing there, there's a 1 here. So really, it's x to the 1 plus 1. That gives us x squared, right? So we get x squared. Then we move right here, 3 times x. So 3 times x. Well, same deal. We do 3 times x. There's really a 1 in front of this, so it's really 3 times 1, which is 3, and then the x goes along with it. So we have this part and this part to put in. So we have 3x. Now we go here, we have x times 4. These meet here, so x times 4, well, you can see if it's x times 4 and there's no number in front, they're just going to glue together. I mean, you guys know I've taught y'all that. If there's no number in front of it, it's just going to glue together, so it'll be 4x. But we do know that there is a 1 in front of this to make it more sense for you. So x times 4 is 4x. Then we have 3 times 4, so these meet right here. So it's just 3 times 4 gives us 12. 3 times 4, 12. Now, we filled up our box, but we got to find the area. We got to find the area as a sum. So we need to add up all these boxes. Well, let's do it. So we have x squared. Always start with your biggest exponent. And as you see, can you see? What do these represent? Well, they're like terms. So I would write your biggest exponent first and then put your like terms. The like term should always be in a diagonal spot. So we have plus 3x plus 4x plus 12. That takes care of each one of the boxes. So do we know where our like terms are? Yes, they're right here. We know what to do with like terms. We just add the coefficients, 7x, and bring down everything else. So there's your answer. That's all you had to do. So your area is the sum when you add up all the boxes. remember, you're combining like terms. Combine like terms. Remember, they have to have the same variable, same exponent, and then you add the numbers in front. So you get x squared plus 7x plus 12. Okay? This is multiplying polynomials. Let's continue. 2 more examples and we're finished. All right, so we have one ready to go. We have 2x plus 8 times x plus 7. Base times height. We know our base is right here. We know our height's right here. And we're going to find the area of each one of these little boxes. So 2x times x, 2x times x. Well, we know the exponent for this, when we're doing x times 2x, it's really, there's an exponent right here of 1. And when there's nothing there, there's an exponent of 1 here. So really this is, and there's a 1 in front of this. So it's really 2 times 1 is 2. And then we do x to the 1 plus 1. X to the 1 times it. So it becomes 2x squared. So the first one is 2x squared. That's probably the hardest one you're going to have to do. Then we go to our next box, x times 8. Well, x times 8, we know there's not a 1 in front of this, so we're going to glue them together. So it's going to be 8x. So x times 8 comes right here. X, I'm not doing that for you guys, sorry. 8x, right? You guys know how to do that. Then the 2x times 7, these meet here, so we have 2x times 7. Well, we don't have a variable over here. We can just do 7 times 2 is 14. Bring the x around with it. So 14x. Then we have 7 times 8 right here. So 7 times 8 is 56. So we found all these to put in our boxes. All right, well, at this point, we add up everything on the inside because we find that this is the base times height, the product, the area is a product. Well, we need to find the sum. Sum means adding up everything on the inside. So I'll write it, because I'm running out of space, unfortunately. I'm going to write it right up here. So we'll start with, we'll have 2x squared, write the biggest exponent first. Then we have our like terms in the diagonal like we wanted it. So plus 14x plus 8x plus 56. Well, do we have any like terms? Yes, right here. So we can just do 14 plus 8 is 22x. And bring down everything else. So there's your answer, 2x squared plus 22x plus 56. We just combined like terms right here. That's all there was to it, and we took care of everything on the inside. So the area is always adding up all the boxes on the inside, and it's also base times height. That's why product is base times height. Sum is just add up everything on the inside, so that's why they're the equal, okay? Last example. We have a base on the top. Oh man, this is going to be difficult. Not really. We can do this. So we go ahead and we start. We start with this. So we have 4x times x. So 4x times x. Well, we know there's nothing in front of x. There's a 1 there. And if there's no exponent, there's a 1 here and a 1 here. So we have regular numbers. 4 times 1. Is 4. Then we have x to the 1 times x to 1. We got to use our exponent properties, which is add the exponents, right? So we have x to the 1 plus 1, which is 4x squared. Okay? So we put that in our first box. So knowing your exponent rules is very important. Now we'll go here. Negative 3 times 4x, which is 4x times negative 3 is times negative 3, and negative times a positive gives us negative 12, and then the x jumps along with it. Okay, negative 12x. All right. We're almost done finding all the areas of these little boxes. So now we have x times negative 5. These meet here. So it'll be x times negative 5. That gives us a 1 here is right here. So it's really, remember, so negative 5x. All right. Negative 3 times negative 5. These meet here. So negative 3 times negative 5. Remember, a negative times a negative is a positive. So that brings that here. Negative 3 times negative 5. Do we have our like terms in diagonal for us set up? Yep, well that means you're on the right track right here, right? So let's write it out. Now we got to find the area as a sum. So we got to add up everything on the inside, and you'll find your answer to multiplying polynomials. So we have, start with the biggest exponent, 4x squared. Then we have negative 5 plus negative 5x plus negative 12x plus 15. That gives us, do we have any like terms? Of course we do. Right here. Negative 5x plus negative 12x more. Remember, if you're digging underground, you're negative 5 underground. You go deeper underground, you're going more into the negative. So negative 5 plus negative 12 is negative 17x. There's your like terms. You're combining your like terms. So then you bring down everything else. Well, that's 4x squared. And your sum, or your answer to multiplying polynomials, is right here. So we get 4x squared minus 17x plus 15. Remember, so product, your areas of product is equal to areas of your sum, and that's how you multiply polynomials.